What if robots existed more than 1,000 years ago? Actually, just pause and really think about that for a second. What if engineers of the medieval world designed self-operating machines, automatic fountains, and literally programmable devices centuries before the Industrial Revolution? Long before modern robotics, three brothers from Baghdad imagined a world of intelligent machines. Welcome to this explainer. Today, we are completely rethinking the timeline of human technology.
Meet the Banu Musa Brothers. We are talking about three extraordinary Persian minds whose 9th century inventions anticipated modern robotics, mechanical engineering, and programmable machines by more than a millennium. Today, we're diving into how their brilliant and honestly largely forgotten ideas helped shape the very future of engineering.
Section 1. Baghdad, City of Knowledge. To truly wrap our heads around their genius, we've got to set the scene in the 9th century Abbasid Caliphate. Baghdad wasn't just a city back then, it was the intellectual capital of the entire world. Around 800 CE, the Banu Musa brothers are born right into the middle of this scientific renaissance. Shortly after, in 813 CE, Al-Hasan becomes caliph, and he kicks off this golden era of scientific patronage. By 830 CE, the famous House of Wisdom is flourishing, and by 850 CE, the brothers publish an absolute engineering masterpiece. This was an era of unprecedented empirical inquiry.
Section 2. The three brilliant brothers.
So, let's meet the team, Muhammad, Ahmad, and Al-Hasan. They were actually the orphan sons of a former highwayman, literally a bandit in Khorasan, who totally reformed his life to become an astronomer and a close friend to the Caliph. When their father died, the Caliph stepped in and took the boys under his wing. Now, even though they published together under one single name, their individual expertise formed this perfectly balanced research team. You had Muhammad, who mastered geometry and astronomy. Ahmad was the mechanical engineering prodigy. And Al-Hasan, he had this unparalleled gift for pure geometry, solving complex problems that had stumped mathematicians since antiquity.
Section 3. The House of Wisdom.
Recognizing their raw talent, the Caliph enrolled them in the legendary House of Wisdom. Think of it as the greatest scientific institution since the Library of Alexandria. But here's the thing, they weren't just passive students sitting in a classroom. They became the primary architects of a massive translation movement. Using their immense wealth, they literally sent agents deep into the Byzantine Empire to acquire rare classical Greek, Persian, and Indian manuscripts and physically bring them back to Baghdad. They were building the foundational pillars of a truly global scientific community.
And their scientific method was incredibly rigorous. Take this staggering number, 24,000 miles. Caliph al-Ma'mun basically challenged the brothers to independently verify the circumference of the Earth. So what do? They go out to the flat desert plain of Sinjar. They measured the altitude of the pole star and then physically walked directly north, using just pegs and a rope, until the star's altitude changed by exactly 1 degree. Their final calculation? A circumference of 24,000 miles, astonishingly close to our modern measurement of 24,902 miles. I mean, wow!
Section 4. Book of Ingenious Devices.
All of this incredible, multidisciplinary genius finally culminated in an 850 CE engineering masterpiece known as the Book of Ingenious Devices. This foundational text of mechanical engineering contained around 100 groundbreaking inventions. About 75 of these were what they called trick vessels, pitchers and basins that behaved in these seemingly magical ways to amuse guests at parties. But beneath the playful exterior of these devices lay some of the absolute most advanced fluid dynamics the world had ever seen.
Section 5. The Birth of Automation. Now, this brings us to their true legacy, moving beyond static tools to build dynamic, automated systems. They became absolute masters at exploiting tiny, super subtle variations in aerostatic and hydrostatic pressures. By manipulating the shifting weight of water and the pressure of trapped air, they created automatic fountains that altered their own spray patterns, and trick dispensers that could pour out wine, then water, driven entirely by internal fluid mechanics.
Okay, let's look at a concrete example of their mastery of feedback loops, a self-trimming and self-feeding oil lamp. It works like this. As the oil burns down, a float sitting in the reservoir naturally sinks. That sinking float pulls a chain, which raises a weight. That movement rotates a toothed wheel, which pushes a mechanical rod that advances the wick perfectly while simultaneously drawing more oil into the lamp. It is a completely closed feedback loop, operating entirely without human intervention. How cool is that? To actually make these systems work, they had to invent entirely new hardware. Enter the conical valve.
This is an inline mechanism that automatically restricts or permits fluid flow based purely on pressure. Modern historians note this was the very first known use of conical valves as automatic controllers in the entire history of engineering. It's an elegant, self-operating solution that requires absolutely no constant manual force.
Section 6. Precursors to modern robotics.
What the Banu Musa were really doing here was laying the foundational groundwork for modern cybernetics. The classical Greek mechanics of Hero and Philo, which the brothers deeply studied, by the way, were largely static, theoretical, and focused on pure geometry. But the Banu Musa evolved this completely. Their mechanics were dynamic, they were empirical, and they were laser-focused on automatic control. They didn't just want to know how a shape worked. They wanted to assign a numerical value to it and build a machine that could literally regulate itself.
When you map these ancient inventions directly to the modern world, the parallels are just staggering. They developed automatic non-manual cranks that anticipated the modern crankshaft by centuries. They designed early fail-safe systems where a vessel would automatically shut down if you tried to draw from it too quickly. They invented double concentric siphons for complex fluid routing. They even built a mechanical clamshell grab for underwater extraction that is virtually identical in its design to the massive industrial grabs we use today. But okay, hold on, because perhaps their most mind-blowing invention was the pinned cylinder. This was a rotating barrel covered in raised pins, used to mechanically open and close pneumatic valves. The Banu Musa used this inside a hydropowered organ and an automatic flute player. By simply changing the placement of the pins, they could change the song the automaton played. Think about that for a second. This was essentially physical, mechanical, read-only memory. This was, very arguably, the very first programmable machine in human history.
The absolute genius of their work is perfectly summed up by modern engineering historian Donald R. Hill. He notes, "The Banu Musa were masters in the exploitation of small variations in aerostatic and hydrostatic pressures, the first known use of conical valves as automatic controllers. Their legacy is completely undeniable. They built the bridge from ancient theory directly to our automated modern world."
Which leaves us with a lingering and honestly pretty provocative question. When you look at your smart thermostat, your automated assembly lines, or the programmable devices sitting in your pocket right now, where does the true history of our automated world actually begin? Because as we've seen in this explainer today, the blueprints for our future were drawn up more than 1,000 years ago by 3 brilliant brothers in Baghdad. Thank you so much for joining me, and keep questioning the history of how our world works.